find out the value of current through this 4 ohm, I can find out the voltage. Let this voltage is equal to V, which I can write I into R. R is 4. I have already found out 0.5 into 4. So it will be 2 volt. So this 2 volt is coming across the 4 ohm only due to 6 volt source. So this is the voltage drop when considering volt source alone. Now I will consider. Now I got the value of voltage across this 4 ohm while considering 6 volt source alone. Next part is I have to consider this 3 ampere source and I have to deactivate this 6 volt source as there is no internal resistance is connected or given here. So this 6 volt source is represented by, or it is replaced by a short circuit. So I can redraw this circuit. So the 6 volt source is now short circuited. This is 8 ohm. This one is 4 ohm. And I am considering 3 ampere source, current source alone. This is 4 ohm. Now I have to find out this voltage across 4 ohm only because of this 3 ampere source. So now I can apply, let this current is I1. Now I can apply the current division rule to find out the current through this 4 ohm. After getting my current value, I can find out this voltage across 4 ohm. So apply current division rule. I1 can be found out by, this is my main current which is injected or which is coming to this node and it is divided into 2 parts. So I can write 3 ampere into, these 2 resistors are connected in parallel. So for this resistor, this one is the other resistance. So I can write main current into the other resistance, other equivalent resistance I can say, and this equivalent, the other equivalent resistance plus the resistance through which I want to find out the current, which is 4 ohm. So I can write into 8, that is 24 divided by 12. So I am getting 2 ampere. Now once I get the value of I1 current, I can find out the voltage across this 4 ohm, which is I into R. That means I1 into 4, that is 2 into 4, that is 8 volt. Now the polarity will be same because the current I1 is flowing from this point to this point, that means high potential to low potential. So this is marked as positive and this is marked as negative. And in the previous page, we have already seen that my voltage only because of 6 volt source was 2 volt, and now I got the value of voltage by considering only 3 ampere as 8 volt. So as the polarity in this case and in the previous case were same, so I can add both the voltages and find out contribution of both the sources towards this 4 ohm resistor. So altogether I am getting 10 volt. So this is the total or net voltage because of both the sources. So this is my answer. The net voltage is across this 4 ohm is 10 volt. And how we got this value? We have considered the individual sources at a time by deactivating the other sources. Then we added the contribution of the sources individually, and we found out this total voltage.